Okay, now we're going to look at page 393, number 13. So number 13, the diameter of a car's tire is 60 centimeters. Okay, so the distance right across 60 centimeters. While the car is being driven, the tire picks up a nail. How high above the ground is the nail after the car has traveled 1 kilometer? Okay, so before we can figure out how high it is, we need to figure out a function that relates the height of the nail in the tire. So it starts by picking it up at 0 height, and it goes all the way up to 60 centimeters as the maximum height. We need to relate that to the distance that the wheel has traveled forward. Okay, so let's take a look at this. So we've got basically we've got a wheel that's moving forward, and we're going to draw the function here. Okay, it's starting off at the bottom, and it's going to go up the nail as it reaches about 30 centimeters. At that point, okay, the nail is right there, and it's traveling upward faster than if it was right here. Here it's traveling this way, the nail, at a certain speed. So part of it's going horizontally and part of it's going up. At this point it's going up totally and not forward or backwards at that instant. And then it slows down in terms of its raising up here until it hits the top. So this follows a sinusoidal function. Okay, and so there's basically 1 revolution of the tire. So the nail starts at the bottom, goes right around, and in 1 circumference we have 1 period of this function. Okay, so that's basically the circumference of the wheel. That maximum is 60 because the tire's diameter is 60. And how do I find the circumference? And the period equals the circumference, which equals pi times d, which equals 60 pi. Okay, so there is the period. Now, t equals 360 over k, which equals 60 pi now. So k equals 360 over 60 pi. Just rearranging these two. Okay, that cancels out and ends up being basically 6 over pi. So k is 6 over pi. The amplitude is going to be right from the middle to the top. So if the middle is 30 here, so the amplitude is 30. Okay, the axis is y equals 30, and it's going to be a negative cos because it starts at the bottom. So no horizontal translation needed. So the height with respect to the distance traveled is going to be negative 30 cos k, which is 6 over pi, times d, and the axis is plus 30. Okay, so now this is our function. And now we can answer how high it's going to be at 1 kilometer. Well, the distance in this equation is measured in centimeters. Okay, so on this axis there's a distance, centimeters, and there is the height in centimeters. Okay, but we're asked to find the how high it is when the distance equals 1 kilometer. Well, 1 kilometer is 1,000 meters, and 1 meter is 100 centimeters. So it's basically 100,000 centimeters. So we want to look at h of 100,000 to find out what this is going to be. So we're going to put 100,000 in for d. And when we do that, we get approximately 59.8 centimeters. Okay, so it's almost right back at the top, which means that the wheel is rotated almost like it could be something and a half turns. Okay, so this would be a full turn if the nail's right back at the bottom. This is a half turn if it's at the top. Okay, and you could check that by dividing the 100,000 centimeters by the circumference, and you'll probably get something 0.5. Okay, so that's that one. The next question we're going to look at is question 9 on page 400. Okay. Question 9 on 400. So I'm mostly just going to set this up and answer the question. Okay, so a paintball is shot at a wheel of radius 40 centimeters. The paintball leaves a circular mark 10 centimeters from the outer edge. So you can see that's where it hits there. Okay. As the wheel rolls, the mark moves in a circular motion. So as the wheel rolls forward, the mark goes like this. So it starts at a minimum of 10 centimeters, and because the radius of the wheel is 40 centimeters, it's going to be 10 centimeters at the max below the diameter of the wheel at the top. So the radius is 40, so the diameter is 80, so it's going to go from 10 up to 70. Minimum 10, maximum 70. The axis is going to be 40. Okay? And in one rotation, the wheel will have traveled forward by one circumference of the wheel. Okay? So in one rotation, the period, so from minimum to minimum, the period is going to be one circumference of the big wheel. Okay, so let's draw this out here. Okay, so here's just a rough sketch of the wheel. Again, okay. I'm just going to do that beside the axis I'm creating here. So there is 10, there is 70, okay, and right at the middle would be 40. Okay. And it picks up the nail, so there's where the spot is. It picks it up here, and then it goes up, the top, not the nail, it's the mark on it from the gun, okay, paintball gun, and goes back down again. So that's one cycle. And that happens in one circumference of the big wheel. Okay. So the circumference of the big wheel, C, well, that's the period, C, equals pi times d, which is going to be 80 pi. And T also equals 360 over K, which is 80 pi. And when we solve this, we get K equals 360 over 80 pi. Cancel the zeros out, and you got 36 over 8 pi, and that reduces to 9 over 2 pi. And now we've got K. We've got the amplitude is from 10 to 40, or 40 to 70, which is 30. So the amplitude is 30. The axis is y equals 40. So that gives us the c value for our function. And because it starts at the bottom, we're going to look at a negative cos. So the function is going to be y equals negative 30 cos of 9 over 2 pi, and we're going to put x here, and then plus 40. Okay, so here is the y-axis, and there's x. So in this case, the y is the height of the dot, x is the distance the wheel has traveled. Okay, and then they're asking for, one of the questions, they're asking for what is the height when it's traveled 120 centimeters. So x equals 120 centimeters. So we're going to plug that in here. And when we do that, we get y equal to 69.7 approximately centimeters. And that should answer that question.